Quick question. What is 1 plus 2 plus 3 all the way up to 100? No calculator. Go on, try it. Most people start adding, then give up somewhere in the middle. But nearly 300 years ago, a schoolboy named Gauss was handed this exact question just to keep him busy. Seconds later, his hand went up. He had the answer. His teacher was stunned. So how did a child beat everyone in the room? He had spotted a hidden pattern. The very pattern that lets you add 100 numbers, or even 1,000 in seconds. That pattern has a name. Arithmetic Progressions. And by the end of this video, you will be using Gauss's trick yourself. Welcome to Chapter 5. Arithmetic Progressions. Picture a cinema hall, filling up. The front row has 12 seats. The row behind it has 14. The next has 16. Then 18. Notice the pattern? Every row adds the same number of seats. To more, every single time. A list of numbers like this, where you add the same amount to get the next one, and it is called an arithmetic progression. The first value has a name. We call it A, and the fixed amount we keep adding is the common difference, that is D. Here, A is 12 and D is 2. So here is the plan. First, you will learn to spot an arithmetic progression in a second. Then, we will find any term you like without counting all the way up to it. After that, we will add up a whole progression using one neat formula. And finally, we will put it all to work on a real challenge. How do you check if a list is an arithmetic progression? Simple. Find the gap between each pair of neighbors. If that gap is the same every time, it is an AP. Take 3, 7, 11, 15. The gaps are 4, 4, 4. Same every time. So, yes. Now take 2, 4, 8, 16. The gaps are 2, 4, 8. They keep changing. So this one is not an AP. One rule. That is all it takes. Back to our cinema. Suppose you want to know how many seats are in row 15. You could add 2, 15 times over. But that is slow. So look closer. To reach row 15 from row 1, you take 14 steps. And each step adds 2. So row 15 is 12 plus 14 times 2, which is 40. That is the whole idea of the nth term. The nth term is A plus n minus 1 times D. And that n minus 1? It is simply the number of steps you jump from the start. Let us use it. In the progression 5, 8, 11, and so on, A is 5 and D is 3. What is the 10th term? Drop it into the formula. 5 plus 9 times 3, which is 5 plus 27. So, 32. And we can go the other way too. Which term equals 50? Set a plus, n minus 1 times D equal to 50. Solve. And you find it is the 16th term. The formula works both ways. Now, for the beautiful part, adding a whole progression at once. Remember Gauss and the numbers 1 to 100? Here is exactly what he did. Pair the first term with the last. 1 and 100 make 101. 2 and 99, also 101. Every pair adds to the same total. There are n terms, so there are n over 2 pairs. And each pair is the first plus the last. So the sum is n over 2 times the first plus the last. Write the last term as A plus n minus 1 times D. And you get the full formula. N over 2 times 2A plus n minus 1 times D. That is how Gauss added 100 numbers in seconds. 50 pairs, each worth 101. 5,050. And now, so can you? Let us try it on something you can see. A shopkeeper stacks tins. 1 tin on top, 2 in the next row, 3 below that, all the way down to 20 in the bottom row. How many tins in the whole pyramid? This is just 1 plus 2 plus 3 up to 20. Here, n is 20. The first term is 1. The last is 20. So the sum is 20 over 2 times 1 plus 20, which is 10 times 21, 210 tens. 20 numbers added in a single step. Now, a real one. You start a running challenge. On day 1, you run 1 kilometer. Each day after that, you add half a kilometer. 2 questions. How far do you run on day 30? And how many kilometers in the whole month? Day 30 uses the nth term, 1 plus 29 times a half, which is 15 and a half kilometers. The month total uses the sum, 30 over 2 times the first plus the last, 15 times 16 and a half, which is 247 and a half kilometers. The same to tools. A real goal. 2 quick things to keep you safe. When a question asks for one particular term, reach for the nth term formula. When it asks for a total, reach for the sum. And always find D by subtracting a term from the one after it, not the one before. Get those right, and this chapter is yours. So, here is the whole chapter in 3 moves. 1. Spot an arithmetic progression by checking the common difference stays the same. 2. Find any term with a plus n minus 1 times d. 3. Add them all with n over 2 times to a plus n minus 1 times d. Cinemas, pyramids, running challenges. All the same maths underneath. If arithmetic progressions finally make sense now, give this a like. Share it with someone who is stuck on it. And subscribe. Next up is Chapter 6. Triangles. Free notes, quizzes and practice are waiting at schoolrevise.com. Revise. Practice. Excel. See you in the next one.